Hello students, welcome to the fourth video of limits and derivatives. So here we shall study about the algebra of limits and a few theorems, and then we shall solve exercise 13.2. So let us see the first thing, there is algebra of derivatives. So to define algebra of derivatives we need two functions, that is f and g, okay, and we shall assume that their derivative exists, that is we can find f dash and g dash. And these two functions are defined on a common domain. So if this f is a function from a to b, then g will also be a function from a to something, okay, that is the domain should be same, fine. Then their algebra of these two functions we can write. Number one, I can take the derivative of the function fx plus gx. If I take their derivative, that will be equal to derivative, that is ddx of fx plus ddx of gx, okay. Similarly for the subtraction, if I take the derivative of fx minus gx, then it will be derivative of fx minus derivative of gx. The second we have is the product rule, or it is also called Leibniz rule. What is that? Leibniz rule, Leibniz, Leibniz rule, okay. So what is that? Derivative of function fx into gx. So if two functions are in the product form, then how to take the derivative? So this is a crucial one, also the most important one. How to do? At first, take the derivative of the first function, that is ddx of fx. Take the derivative of the first function, then keep the second function as it is, plus derivative of the second function, or keep the first function here into derivative of the second function, okay. So this is how we find the derivative of a product rule, or in other words you can write, easy to memorize, like if you want to find the derivative, to consider this as u, consider this as v. So uv dash will be remembered as u dash v into plus u v dash, okay. So this is quite easier. Now the third one, also the another important one, there is derivative of the function of quotient form, that is fx by gx. This is called the quotient rule, or in other words it is said quotient rule, okay. So how to find the derivative of this? In this case you need to write the gx square here. This denominator will become square, and then write the denominator here first, and find the derivative of the numerator, that will be fx minus, here it was plus, here it will be minus. Write the first function and derivative of the second function, that is gx, okay. So even if you don't give the bracket, it's fine. So these are the basic formulas. In other words, you can write u by v dash can be written as v square this is your v square, so v u dash minus u v dash, okay. So easy to memorize. And the proof of these identities, I am just skipping them, you can check it using the first principle. You can take any of the functions and you can see whether these equalities are same or not. So now we have a few formulas for the derivative of few functions. So let us see the first one. Here we have ddx of x to the power n, that is equal to n into x to the power n minus 1. So I am skipping the proof here because to find this proof we need induction as well as the binomial theorem, so both are reduced from the syllabus, and this is actually the parent formula, and from this we get all this 1, 2, 3, 4, 5. Like if I raise the power of x to 1, so according to this formula the answer of ddx of x to the power 1 will be 1 into x to the power 1 minus 1, and that will be 1 into 1, that will be 1, so we are getting 1 here. Similarly ddx of x square, that will be what? 2 into x to the power 1 minus 1, 2 into x to the power 2 minus 1, and that will be equal to twice x, okay. Similarly this you can find it using the first principle. Okay, and also you can find it like this, like ddx of x to the power minus 1. So it will be what, minus 1 into x to the power minus 1, and that will be equal to minus 1 into x to the power minus 2. So this will give us minus 1 by x squared. What about this? This is giving actually x to the power ddx of root x, means what is root x? X to the power half. So since it is a real number, I can write half into x to the power 1 by 2 minus 1, and that will give us 1 by 2 x to the power minus 1 by 2. So I shall be remaining with 1 by 2 root x. Okay, so this is our answer. And what about this, the last one, ddx of any constant is 0. So a very important one. So whatever constant we are there, that means our ddx says that it is the rate of change, isn't it? So if it is a constant, like if I take a constant velocity, so if I want to change it with respect to time or anything, so a constant cannot be changed, isn't it? So it is always 0. Now we have few more formulas, that is ddx of sin x is cos x, ddx of cos x is minus sin x, ddx of tan x is sec square x, ddx of cot x is minus cosec square x, ddx of sec x is sec x tan x, and ddx of cosec x is minus cosec x cot x. Also there are 3 other formulas that you will be getting in your grade 12, that is ddx of e to the exponential function is the same function, ddx of log x will be 1 by x, ddx of a to the power x is a to the power x into log of a. So these 3 you will be getting in your grade 12 specifically. And all these formulas can be find out, or these results can be find out using the first principle of derivative. Okay, so now let us see this first one, how it came. How ddx of sin x is cot x is a cos x. Let us see that. So here let us consider y is equal to f of x, and that is your sin x, or you can consider fx is equal to sin x. Now what does the first principle say? F dash of x will be equal to limit h tends to 0 f of x plus h minus f of x divided by h. So in our case, what is the function? It is fx is equal to sin x. So what about f of x plus h? It will be sin of x plus h minus, in place of fx it will be sin x divided by h. So limit h tends to 0. Now what about this? We have got the formula in our trigonometry, that is sin a minus sin b. So what is sin a minus sin b? That is equal to 2 cos a plus b by 2 into sin of a minus b by 2. So use that, we can use this formula here. So it will be twice of sin a plus b by 2, that is x plus h plus x by 2. Sorry, this will be cos according to the formula, and this will be sin here, sin of a minus b, that is x plus h minus x by 2 divided by h. So here we have limit h tends to 0. I can write the 2 by h here, and along with cos of x plus h, this will be twice of 2x plus h by 2 into sin of h by 2. Fine. Now what is that is equal to limit h tends to 0, and this 2 by h I can write in the denominator of h by 2 just by taking the reciprocal of that. So this will be cos of, I can divide the twice x by 2 plus h by 2, I shall be having it here, into sin of h by 2 whole divided by, I can take the reciprocal of this and bring it down there, so it will be h by 2. Now since these two are in the product form, I can, if I take the limit, how will it be operated? So this will be equal to limit h tends to 0 cos of x plus h by 2 into limit h tends to 0 sin h by 2, and here h by 2. Now one more thing is that h tends to 0 is same as h by 2 tends to 0, because if here h tends to 0, h by 2 suppose if in place of h if I put 0, so this whole thing 0 by 2 will also be 0, isn't it? So writing here h tends to 0 and h by 2 tends to 0 is same. So actually we are writing h by 2 because we have here h by 2. Okay, now what is that? We have got the formula, that is limit x tends to 0 sin x by x is equal to 1. So we shall be using that here. So this gives us, if I apply the limit on both sides, so this will be 1, this term will be 1 into, since here I can apply the h here because it is not undefined. So if I put here h 0 by 2 will be 0, so I shall be remaining with only cos of x. So cos x into 1 is our cos x, and so this is the derivative of your sin x. So this is how we find the derivative of a particular function using the first principle. So now we have exercise 13.2. Let us see the first question. Here it is, I have taken question number 2, that is find the derivative of 99x at x is equal to 100. So there are two ways to do it. One is using the first principle, and probably you will be getting only 1 mark here, so no need to do by that. And if the marks are high like 3 or 4, then just use the first principle. Okay, now to find the derivative of this, so let me take fx is equal to 99x, and I want to find the derivative at the point x equal to 100. So at first find the derivative. So what is the 99x? And it will be 99. How? Using ddx of x to the power n, and that is equal to nx n minus 1. Since 99 is our constant, bring the constant out, and x to the power 1 minus 1 is 0, 1 minus 1 is x to the power 0, and that is equal to 1. So we have got 99. Now f dash x at the point 100, since it is already a constant, so can we apply the 100 here? No, because there is no x remaining. So this is our final answer. Now let us see question number 4. In question number 4, they have said to find the derivative of the function using from the first principle. So we have the function 1 by x square. Let us see how to find it using the first principle. So for that, let us consider fx is equal to 1 by x square. Now what does the first principle say? F dash x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. Now what is that? Is equal to limit of h tends to 0. In place of f of x plus h, see, when the x was fx, we have got 1 by x square. If it is x plus h, it will be 1 by x plus h whole square minus, what is fx? 1 by x square divided by h. Now that is equal to limit h tends to 0 divided by h, and you can take the LCM of this, so it will be x plus h, or you can directly write it below, same thing, x plus h whole square into h into x square. So here I shall have x square minus x plus h whole square. In the next line, see, we can apply the h here, okay, since we are applying the limit, so we can directly apply the h here, but the thing is that if we apply h on both sides, it will be a 0 by 0 form, so we need to simplify it further, that is, we need to cancel out the h from here. Okay, now limit h tends to 0, if I break it, we shall have x square minus x square minus h square minus twice xh divided by h x plus h whole square x square. So x square and x square will get cancelled, and then we can cancel h and 1h from here. So this will give us limit h tends to 0. If we simplify it more, so I can write, taking the negative common, h plus twice x, and below we have x plus h whole square into x square. I can apply the limit, so it will be minus twice x divided by x square into x square I can cancel out 1x, so this will be minus 2 by x cube. Okay, so that is the answer. Now let us see question number 7. So now we want to find the derivative of this function, that is x minus a into x minus b. Here a and b both are constants, it is given in the question. So for that, let me write fx is equal to x minus a. See, this x will depend on what the variables are. If it is y, so just write y. If it is something like t or something, just write t. Okay, so now one thing is that since it is in the product form, isn't it? So we know by Leibniz rule we can find the derivative of a product of two functions which are in the product form. Also what you can do is that just multiply them. X square minus ax minus bx plus ab. So this will give us x square minus a plus b into x plus ab. So this is quite easy to find the derivative. Like you can simply, since it is not using the first principle, so you can directly do the derivative. So derivative of x square will be twice x minus, this is a constant, so it will be a plus b, and derivative of x is 1 and this will be 0. So this is the first derivative of this. Also if you want to do it in the product form, like using the Leibniz rule, then d dx of fx will be equal to what? The derivative of the first function, that is x minus a into x minus b, keep it separate, plus keep the first function here, then derivative of the second function, that is x minus b, and that is equal to derivative of x minus a using the algebra, that is derivative of x minus derivative of a, and derivative of x with respect to x is 1 and derivative of a with respect to x is 0 because a is a constant, into x minus b plus x minus a into derivative of x with respect to x is 1 and derivative of x with respect derivative of b with respect to x is 0, so we are not adding that. So our answer is x minus b plus x minus a. Fine. And if you want to write it more precisely, we can write twice x minus of a plus b. So we are getting the same answer just like the previous one. Now let us see question number 9. In question number 9, what they have done, let us see question number 5. Question number 9, Roman 5, that is x to the power minus 4, 3 minus 4 to the power minus 5. We want to find the derivative of this, and this is what? A polynomial function. So let us consider y is equal to, okay, find the derivative. They have not asked to find it using first principle. So let us write fx is equal to x to the power minus 4, 3 minus 4 x to the power minus 5. Now either you can do it in the product form or you can break it also. So this will give us 3 into x to the power minus 4 minus 4 into x to the power minus 4 into x to the power minus 5, and this will give us x to the 3 into x to the power minus 4 minus 4. The powers will add up, so this will be x to the power minus 9. Now what to do? Therefore derivative of x with respect to x will give us 3 into x to the power minus 4. Our formula was what? d dx of x to the power n will give us n into x to the power n minus 1. Now in place of n, what we have? We have here minus 4. So keep the 3 aside. Now we shall be writing here minus 4 because we need to write it n here into x into n minus 1, that is minus 4 minus 1, minus, we have a constant here, take the derivative of this, so it will be minus 9 into x to the power minus 9 minus 1, and this will give us minus 4 into 3 minus 12, so x to the power minus 5 minus minus plus 9 4 36 x to the power minus 10. So this is our answer, quite easy. And the same thing if you want to do using the first principle, it will be quite lengthy. So it will depend on the question, that if it is asked that find the derivative of a function using the first principle, then only you can do the first one. Otherwise you can directly do it using the formulas. So the first task will be to memorize the formulas. Basically you cannot recall them suddenly if you do not know. Okay, so that will be the end of this video and also the end of this chapter, and I'll be solving many more problems in the PDF. So please go through them, and if you have any doubt, like if you are finding any doubts in anywhere throughout the chapter, just feel free to contact me anytime. And yeah, that will be the end. Thank you.